Welcome there, my viewer. This is your friendly neighborhood astronomer, Njorogemosesn. Today, I want to do yet another astronomy video. And in today's video, I'm going to demonstrate this phenomena that you can see right here that is being demonstrated. This is a simple animation that I've done using Stellarium. And in this animation, you can see it is tracing the path followed by the sun throughout or over a period of 1 year. Now, this astronomical phenomena that you can see here is what I want to discuss. Not only will I discuss and name it, we shall also look at how to reproduce it practically, if it can be able to be done practically. Thirdly, I'm going to talk about the orientation and the shape of that phenomena. Fourthly, what I want to discuss is the reason behind that astronomical phenomena. And finally, we shall try and investigate whether this phenomena is unique to planet Earth. In other words, does this phenomena also occurs in other planets? So stick around until the end so that you can be able to get the full information that I want to present to you today. Thank you and welcome. That animation that you have just seen, or this animation that you can see right now over here, is what is referred in astronomy as a solar analemma. Now, a solar analemma is simple, or it is simply a curve resembling an elongated figure eight. You can see from this pattern over here, the sun is varying its position at the same time over a period of 1 year. Now, this pattern that is being formed is what is known as a solar analemma. If you want to define it, you can say something like this. A solar analemma shows the sun's varying position at the same time over a period of 1 year. Or if you want to give it another definition, you can say a solar analemma is the position of the sun in the sky at a single fixed location throughout the year. And this animation basically shows you what we refer to as a solar analemma. In another way, you can look at it, or maybe you might not have thought about it, but the sun does not rise and set at the same fixed position in our skyline. The position of the sun changes each day from one day to another. And as it changes, it creates this pattern that you can see over here, this solar analemma. So the next thing I want now to talk about is how to demonstrate or how to create a solar analemma. Now, to demonstrate a solar analemma is simple, but requires a lot of hard work, a lot of consistency, and a lot of accuracy, because if you're off by just a few measurements, your solar analemma, the final product, will not be very accurate. But let's say, for example, on the 1st of January will be a good day to start taking your measurements, because you want to take it for a period of 1 year. Go outside, put a stick on the ground. Now, mark the position of the end of the shadow that that stick makes. Mark the position of the end of that shadow that the stick makes. Now, do this every single day at the same time for a period of 1 year. Now, what will you notice? You will notice that the sun changes its position day after day. In short, the sun does not rise and set at the same position each day. The sun is a little bit more to the east. The tip of the shadow of that stick that you stuck on the ground will trace what is known as a solar analemma. Just to digress a little bit, I was just thinking that this solar analemma is actually one of the best proofs, not one of the best, but one of proves that we live in a heliocentric solar system, or a heliocentric universe. Check my other video where I demonstrated what is a heliocentric model. Now, I have seen quite a number of videos that have been promoted by flat earthers on TikTok and on YouTube, where they quote verses like Psalm 104 and Psalm 93, trying to talk about a flat earth and a geocentric model of the universe. But personally, I believe they're taking these verses out of context. And the reason why the Bible has this geocentric like kind of model is because it's a convenient reference frame. Now remember, something like a planetarium uses also a geocentric model. Also calculations of the rising, for example, transiting of planets or setting of various celestial objects is also calculated geocentrically. Since astronomers often use the Earth-centered reference frame, it is unfair and unscientific to criticize the Bible for doing the same. So solar analemma for me is one thing that I don't know how flat earthers would explain it in their model of their universe, but it is best explained using a heliocentric model. And this is going to be seen later in my discussion. So the next thing I want to discuss is the shape and the orientation of this solar analemma. So let us now jump in and discuss this shape and the orientation. Now to discuss this shape and the orientation of a solar analemma, I'm going to consider three scenarios. One of them is at the equator, and the other one is at the northern hemisphere, or the other one will be at the southern hemisphere. We look at how the shape and the orientation of this solar analemma looks like. I will start with the first one at the equator, because by default my stellarium I've set it at the equator. So let me log into stellarium and then you look at it. When you log in at stellarium and now you look at the position, sorry, not the position, but the shape and the orientation of your solar analemma, you will realize that at the equator, the analemma looks as if it's on its side. You can see from here, the analemma is like lying on its side. You understand what I mean by that, lying on its side. Looking east, the smaller loop, look at the smaller loop and the large loop that is being formed. The smaller loop is towards the left side. And if you were to look at the position of the analemma, or the shape and the orientation of the analemma east westwards, you will realize that the small loop is towards your right hand side. If you look at it on the rising sun, it's towards your left side. If you look at it towards your west on the setting sun, it's on your right hand side. That is the small loop. So this is how it looks like when you're looking at the analemma if you're positioned at the equator. If you are on the North Pole, or sorry, not the North Pole, sorry, but if you're on the Northern Hemisphere, countries that are on the Tropic of Cancer and upwards, for example, let me pick this one, and then look at how it will look like. So this is a country on the Northern Hemisphere. I've just picked a random one. On the Northern Hemisphere, it is tilted at an angle with the largest loop at the bottom. So you can see now how the shape and the orientation looks like from the Northern Hemisphere. So now let's look at it from the Southern Hemisphere. Now these are countries on the Tropic of Capricorn and below, for example, South Africa. Let's pick at one of a random city around there. So from South Africa, which is at the Tropic of Capricorn, which is at the Southern Hemisphere, you will realize now it is inverted as compared to that one of the Northern Hemisphere. So here in the Southern Hemisphere, it is inverted. The largest loop is at the top, but still tilted at an angle. I hope you can see those differences. So my viewers, that is how the shape and the orientation of a solar analemma looks like when you look at it from the equator, when you look at it from the northern hemisphere, and when you look at it from the southern hemisphere. So let us now move on to the reason why we have a solar analemma. Now, there are two main reasons for a solar analemma. The first one is the axial tilt of the Earth, and the second one is the elliptical orbit of the Earth around the Sun, or the eccentricity of the Earth's orbit around the Sun. Now, the axial tilt of the Earth, which is around 23.5 degrees, is the one produces, or the one that causes, the up and down movement of the Sun as viewed from the Earth. In that solar analemma, you can see at one position the Earth is on this end, and the other time is at that end. That up and down movement is as a result of the axial tilt of the Earth. Now, the side-to-side movement of the Sun in the solar analemma is as a result of the elliptical orbit of the Earth around the Sun. Here, my viewers, kindly go familiarize yourself with the 3 Kepler laws of motion. At one particular point, when the Earth is near the Sun, it will have a higher orbital velocity as opposed to when it's on the other side. It will have a slower orbital velocity. That is when it is at the perihelion and the aphelion position when it's orbiting around the Sun. So those are the two main reasons that causes the solar analemma: the axial tilt and the eccentricity of the Earth's orbit. Just to mention here, a quick mention, at the equinox, when we get the same amount of daylight and nighttime, happens to be the middle of a solar analemma. And actually, if you measure the angle that is formed, you will see it is equal to the Earth's orbital tilt of 23.5 degrees. So with these two reasons, I believe, as I had stated earlier on, that this data best fits in a heliocentric model because of the elliptical orbit of the Earth and the axial tilt. These are the two main reasons that produce this solar analemma. And without these two, which actually miss in a geocentric model of the universe, you cannot have, or you cannot explain this solar analemma. So because of these two reasons, axial tilt, elliptical orbit, we are able to get a solar analemma, and this data fits perfectly in a heliocentric model of our universe. So since an analemma is produced by the elliptical orbit of a planet, this means that other planets will also have their own solar analemma, because in a heliocentric model of our solar system, the planets or the other planets also revolve around the Sun. Therefore, if you are not a visitor, if you are an astronaut, for example, who has visited Mars, which has an axial tilt of 25.3, I will confirm, but it has an axial tilt which is similar to that of Earth, it will form a pear-shaped kind of solar analemma. Actually, you can see from this photograph that I've just gotten from the internet, this is a picture that was taken from Mars, and you can see they have traced the solar analemma that is seen when somebody is on planet Mars. So the last question I want to answer is, do other planets have a solar analemma? Yes, other planets have a solar analemma because they have different elliptical orbits. So my viewers, let me show you this last photo. This photo shows you the solar analemmas are seen from different planets. You can see from here for planet Venus, it's an ellipse. You can see for planet Mars, it's this teardrop. You can see for planet Jupiter is an ellipse. And you can see for planet Saturn, it's a teardrop with a tiny loop at the end. Finally, you can see for Uranus and Neptune, we have this figure 8. So my viewers, yes, other planets have solar analemmas, and we have been able to verify and demonstrate why they do have them. It's because of their different elliptical orbits. So thanks for watching until the end. Let me know your feedback if this video has informed you and you have been able to learn something new. So stay tuned for the next upcoming astronomical video that I'm going to make. Bye bye.